Right now. But can you
I
increase
can.
you punya volume tu? Tak berapa nak dengar lah.
Oh, okay. Wait.
Ah, bring your mic closer to your ni lah, lips. Okay.
Okay. How about now, Doctor?
Okay. Much more clear.
Okay.
Thank you very much. Okay, you may start now.
Okay. First of all, can you see my screen?
Not yet. Just
Okay.
now I can see it, but not now.
Okay. I will share the content right away. Okay. How about now?
Okay. Now.
Okay.
Okay.
First, I will like to start with my introduction. My name is Muhammad Raziq bin Roslan, and I am from Group B, Group AB, and also my final times in UiTM. Okay. I am under supervision of Meda Akila binti Dola, and my purpose title will be the application of magnetic molybdenum disulphide on crude oil, and also the effect on the wettability alteration. Okay. So next, I would like to do the introduction on my topic, which is actually magnetic molybdenum disulphide is can be considered as nanoparticles. And before we start defining what is molybdenum sulfide, I would like to introduce what is nanoparticles. Actually, nanoparticles are a common or the a method that is considered magnetic, organic, and organic, which are solely used in the application of different sector. So as I am in the oil and gas sector, so my focus will be on the nanoparticles application in the oil and gas sector. Okay. From the previous journals or studies, it shows that nanoparticles are commonly used in drilling application, enhanced oil recovery application, and also high pressure, high temperature drillings. The presence of nanoparticles is the process by acting as alternative for their usual substances. So in my project, I will synthesize magnetic molybdenum sulfide using the bulk powder, which is molybdenum sulfide itself. And after I finish synthesizing the samples, I will the sample will undergo four different categorization, which will be FAIR, XRD, BET, and particle size analysis. All the categorization are needed and crucial in order to determine that my project or my samples can be considered as nanoparticles. So after characterizing the all the samples and the next will be the usage of the sample in order to measure the wettability or to determine the whether that the sample can alter the wettability, which is commonly used in the oil and gas sectors. Okay. Uh, so the as I mentioned before, the objective will be to synthesize and characterize magnetic molybdenum disulfide. This is my first part. So the second part, which is the final part, will be to investigate the effect of magnetic MOS2 towards wettability alteration. Okay. My problem in making this project work is if I'm not mistaken, there are few all not enough particles or reference specifically on magnetic molybdenum sulfide. However, I managed to pull through to the project because there are many or variety reference or journal that use another nanoparticles such as graphene oxide nanoparticles, silver nanoparticles, and other organic nanoparticles, which are already implemented in the oil and gas sector, especially in enhanced oil recovery. The second problem in this project will be, as I mentioned before, as there are less journals and studies. It is there is a presence of uncertainties whether that magnetic MOS2 can be used as alternative for another nanoparticles in the oil and gas sector. And as one of the new nanoparticles in the industry, the pioneer, the magnetic molybdenum sulfide will suffer or face fierce competition against another nanoparticles that already established their usage and usefulness in the sector. Okay. Next, I would like to explain on the methodology of my project. So, my first will be the synthesis of magnetic MS2. In this So I will like to explain how the process in synthesizing the magnetic MS2. First of all, we have the powder of MOS2 dissolved into pure water 250 ml. Then the disperse of the solution will be undergoes ultrasonification using ultrasonic. Okay, the crucial this method is crucial in synthesizing because the ultrasonic cleaner are made to exfoliate the MOS2 before we can proceed to the next step. Okay, the exfoliation is needed to convert the carboxylic acid group into carboxylate anions, and also um, as the main characteristic of MOS2 is that is considered 3D structure. If I'm going to explain with in the crude matter. Imagine you have three stacks of paper. Then the paper after explorating the three stacks of paper are separate into individual stacks. So after when the stack is separated, it's easy to coat with another material, which is in the next step with the usage of iron 2 chloride tetrahydride and iron 3 chloride hexahydride. Okay, both of the chemicals are dissolved into pure water, and then um, the solution that I ready the solution of iron 3 and iron 2 chloride is put into the MOS2 powder MOS2 solution dropwise. This is to ensure that the coating or the ion exchange can be performed efficiently. Okay, after okay while dropping the solution of iron 3 and iron 2 chloride, it is the mixture is needed to be stirred at continuously and under the nitrogen flow of 40 L per minute. Okay. After after that, the mixture is added ammonia solution of 30% concentration in order to ensure that the pH value will be 10 because the needed synthesis of iron oxide nanoparticles require 10 pH. Okay, after we get 10 pH, uh, the solution will be heated by the heating metal. As you can see here, this is the heating metal. The heating metal about 2 hours and at about 90 degrees Celsius. Okay. In order to determine or to ensure that the mixture is 90 degrees Celsius, we take the temperature using thermometer in 5 minute interval to ensure that the range of the temperature is within our expectation, which is 90 degrees Celsius. Okay, after that, we age or cool the black precipitation by leaving it without any stirring for 24 until 48 hours. Then after aging and cooling, we wash the this black precipitation with the ionized water in order to reduce the pH value into 7, which is neutrality. Then the final step will be the drying of the samples. Okay, so that is the synthesis of magnetic MS2. So the next will be characterization of magnetic MS2. As you can see in my screen, there are four: FTIR, XRD, BET, and zeta sizer or PSA. Okay, all of the result will be discussed further on the result and discussion tab. Okay, next, in my methodology will be the performance study. As I mentioned before, my main focus will be the contact, the wettability alteration. So, in order to determine the wettability alteration, the usage of contact angle goniometer is used. Okay, after completing all the three initial steps, then we will proceed to the result and discussion. Okay, in the results, my first discussion will be the product or the sample produced in my synthesis. As you can see, this is on the left hand side. This is my setup, my experiment setup in order to synthesis, and in the right hand side, you see this is the powder created or synthesized for my experiment. as you in the picture, you can see the magnet are being used to ensure that our sample possess magnetic properties. Dr. Hidayati Osman says, our faculty are lacking in equipment to determine magnetic properties. Therefore, a simple method of visual inspection are used to ensure that the magnetic properties can be seen. However, the reaction of magnetic molybdenum sulfide with the magnet are weak in this picture because the stronger magnet or more magnetic, higher power magnetic can be used to show stronger reaction. Okay. Next, we'll talk about or discuss about the characterization of magnetic molybdenum sulfide. As you can see, the first one will be the Fourier transform spectrometer (FTIR). Okay, the FTIR is made to show or to define the structural changes in the magnetic MOS2. So the first structural changes will be as you can see, the 3220.74 is considered under. Okay, before I further explain it, all my analysis for FTRR made during infrared correction table, which are in the range of the per centimeter. They will show the functional group. So the first functional group will be the OH bending, which is considered as alcohol. Okay. In this the first analysis is used to compare the structural changes or the functional group between magnetic MOS2 and magnetic graphene oxide. As I read through journals and past study, magnetic graphene oxide also shows that it has OH bending in their structural crystal structure. Okay, so the next one will be 2145.2. This will be the C triple bond H stretching, and the final one will be um, C double bond C bending, which is considered as aromatic groups. Okay. The function of determining the functional group is that to ensure that the most suitable or what the accepted functional group can be applied in in the oil and gas sector, as most of the nanoparticles that are already established also considered to have OH bending, which is alcohol groups. Okay, for the next one will be X-ray diffraction spectrometer. Um, the SRD is used to determine the diffraction peak for our sample. Okay, before that, I want to explain the left hand side. The left hand side is actually the graph produced before we start before I start the synthesis of this magnetic molybdenum sulfide, because I want to ensure that the received bulk powder of molybdenum sulfide is genuine, or in other terms is what it is original or can be used before I start synthesizing. I compare it with one of the previous studies, and the diffraction peak I gained from my XRD is the same as the past studies. That shows that the chemical that I receive or the powder that I receive is really a molybdenum disulphide. Okay, on your right hand side is the graph, the suppression peak after the MOS2 gain magnetic properties. As you can see, the intensity is uh, is very erratic when compared to the bulk powder MOS2. Okay. Next characterization will be the zeta sizer. This is actually one of the most crucial characterization to determine that magnetic MOS2 is considered as nanoparticles. So what is particle size analysis? As it names mentioned, is actually to determine or measure the particle size of my samples. So after after the characterization, the sample shows that it has 73.74 nanometers, which falls under the category of nanoparticle size. In previous study stated that the nanoparticle size are in range between 0 until 100 nanometers. So as I mentioned before, the sample is 73.74 nanometers, which is considered nanoparticles. Before that, the usage of particle size analysis have a strict requirement, which is the samples of powder must be grind into as thin as possible, and the obscuration or the light scattering usage in order to disperse must be 10%, because the ascos material require higher obscuration of light in order to gain the results. So due to the uncertainties of my initial states of my product, 10% is considered the max as obscuration set by the person in charge in analyzing my particle size sample. Okay. However, as I read through journal, higher obscuration is needed if the sample are considered coarse or big in size. Okay. The last categorization will be the BET, Browner Emmett-Taylor. Okay. Actually, my first plan will be to just use the BET to gain the surface size. This is my initial plan. However, after learning with the proper person in charge on how to use BET, it is said that BET can produce a lot of information such as surface size, pore volume, pore size, and also the absorption graph. Okay. In on the left side of BET, you can see a graph. It's actually a quantity absorbed of gas against relative pressure, and the relationship between the quantity absorbed of gas and relative pressure is that it is increasing as the relative pressure increase. Okay. Um, for the surface size, the magnetic molybdenum sulfide shows that it has 60 meter square per gram, and then the surface size I compare it with magnetic graphene oxide. Magnetic graphene oxide has about 70 meter square per gram. It shows that the magnetic molybdenum sulfide can be considered as to exhibit the same characteristic as magnetic graphene oxide. Okay, the next will be the pore volume. The pore volume is 0.22 cm cube per gram. And next, I will like to explain that why I keep comparing molybdenum disulphide with graphene oxide. It is because both of the materials are considered to exhibit the same properties. One of the same properties is that both are considered to have mesoporous pore volume. What I mean by mesoporous is as nanoporous pore size, which range between 2 until 15 nanometers. As you can see, my samples, magnetic molybdenum sulfide, have the pore size of 136 angstrom, or if we convert it to nanometers, you have 13.6 nanometers. And then we can easily conclude that that my magnetic molybdenum sulfide is considered as nanoporous and fall under the range of nanoporous size. Okay, last in my project will be the performance study, wettability alteration by measuring the contact angle. In order to perform my study, this performance study, I prepare 3 different concentration, which are 5% weightage, 50% weightage, 25% weightage. Okay, why I go through all the hassle to prepare 3 different concentration? Because supposedly, in theories, the concentration increase will affect the decrease of contact angle. Means that before that, I will the relationship between contact angle and wettability is the lower your contact angle, the higher the wettability are considered to exhibit by the materials. And as you can see, the 5% concentration has the highest contact angle, which is 49.10. and followed by 50% concentration. They're slightly lower than the first one, 41.2, and the last concentration is 25, the lowest, and exhibit the lowest contact angle, which is 35.4. Okay, from this, we can determine that the higher concentration of nanofluid or nanoparticles will affect the wettability alteration. Therefore, if we need to use what wettability alteration in application of drilling, you we can manipulate the concentration to ensure that the productivity of fluid in oil reservoir can be can be can be done. Okay. Um, First, next, I would like to explain on how this performance study are made. Okay, first of all, actually the performance study are made by using core samples and also core samples and crude oil, heavy crude oil. But due to absence of ability such as core samples and as the know, core sample can cost a lot. I I I try to ask Dr. Wan to how to obtain the core samples from reservoir, and it costs almost 400 MIR for one core sample. So for in order to find the alternative, the glass chip is considered glass chip is used as substitution, and then immersed in cooking oil, which is the alternative for heavy crude oil. Okay, and then the as you in the picture, actually the droplet is point on the glass chip that is immersed by crude oil, which in this case is cooking oil. Okay. So my conclusion is that after all the characterization, all the performance study, I can conclude that magnetic MOS2 can be considered as a nanoparticles, as both characterization and performance and result is being compared with another nanoparticles and shows that it falls under the category of nanoparticles. However, um, I I am unsure whether the real application of MOS2 can be done, as in my recommendation, higher intensity of research and experiment needed to perform and utilize the application of magnetic MOS2. And also uh, one of another recommendation is that um, the performance study and characterization can be more efficient if I grind the powder into thinner and smaller size. Okay, that is all from me.
All right, thank you very much, Raziq, for your interesting presentation. So basically, can I ask like you punya satisfaction towards you punya research project ni, how many percent basically?
Okay, based on my understanding, I will rate it about 90%. Okay, because the nanoparticles are actually an interesting topic. Uh, this is this is my consider as my first confession. Actually, the first time this is the first time I heard about nanoparticles when I received this topic. So it interests me. So I read a lot about nanoparticles, and when my supervisor decide that I need to perform an experiment, I was delighted because I can evolve on how to synthesis one of the nanoparticles. Even the nanoparticles are considered to be minimals or um, uh, lack of synthesis. Uh, in when in term of
Okay,
make
Raziq.
ah wait
Yes.
hello.
Okay, all right. Yes. All right. So even though your research project is not completed, but you still satisfied with it, or how?
Yes. I still satisfied with it. I just say it's not completed. That because my SB says this is just one of the analyze and whether that to prove that MOS2 can be considered as nanoparticles, and I said that uh, I succeed in synthesizing nanoparticles based on all the characterization. So overall, I'm very satisfied with the experiment.
But how can you prove that MOS2 is a good nanoparticle as compared to the others? I mean, like, how do you justify it is a good in terms of altering the wettability of the Nila of the
Okay.
rocks? Mm.
I actually compare it with silica nanoparticles, I think. By reading all the success usage of silica nanoparticles in wettability.
But you didn't do a comparison. I mean, like experimental comparison with the silica
Oh, yes, I
and
did.
nanoparticles.
Uh,
So how can you confirm?
oh, just in my case, I just can confirm it just through the result of the contact angle. It says that higher concentration will decrease the contact angle. So as and the theory and my result is fulfill that theory. So that's why I consider it as successful. However, if I want to compare it in real life application, I think the MS2 needed more exposure or research by professional before I can
You
say
you
this.
mentioned you mentioned the higher concentration of the MOS2, it will lower the contact angle. You want the lowest contact angle as possible, is it?
Yes, yes.
But if you add 100%, what going to happen to the contact angle?
Okay.
Is it going to become zero?
No, no. Actually, it's not, the wettability alteration. It's not always the best that we needed. The lowest contact angle. We needed to manipulate the concentration.
Hmm.
To suffice the permeability or the reservoir in the oil and gas
So what is the value of contact angle that you want basically? And
uh
why you stop at the 35.4?
okay. This is just a comparison between concentration. So for that question, I don't think I can
So
compare it
that
with
is
real life.
what I said. Your study is not complete. So by doing only MOS2, you could be biased to your results, and some
Yes.
more you didn't prove the wettability of I mean like the wettability of the one that you want to reduce, the contact angle that you want to reduce by using the MOS2, because you didn't compare with the silica and other nanoparticle things. And then how much is the the MOS2 that you use?
For both consideration,
The price of MOS2 as
the
compared to
price.
the silica.
Oh,
Pernah tanya
about
tak berapa dekat lecturer? How much is the MOS2 punya harga?
about that, I don't ask, but I know the price of for because I
Can you Google after this? The price
okay.
of MOS2 is very, very, very expensive. So itu baru partially from you punya result. So basically, I know when we are doing the wettability, the most important thing we need to check on the contact angle. So the contact angle that you put in here, how many times do you run?
3 times.
3 times only. The
Yes.
one the value that you put over there is the average or what?
The average.
The average. So the one that you use is dynamic contact angle or static contact angle?
I think dynamic. As Puan Azizan mentioned.
Static.
Yes. Dynamic.
Dynamic is over time. Maksudnya once you drop benda tu, 1 second, 2 second, 3 second, what going to happen to the droplet? Is it the droplet will stay at that ataupun dia akan akan
Stay.
pecah terus? So maksudnya ini adalah static contact angle. So the most appropriate contact angle that you need to use is dynamic contact angle because you are using the wettability. So upon the time, perhaps the contact angle will reduce, maybe due to the how to say the nilai interfacial tension of the droplet itself. And then some more,
Sambung. Sorry. Uh, not clear about the question.
surface
Uh,
energy you check.
okay.
Hello?
Sorry, doctor.
Ah,
My connection is poor. Can you repeat what you say just before?
Okay, other than by using the content, let's say lah, you're going to proceed the same title, the same topic while you
Yes.
doing the master atau PhD project. So I would suggest instead of just using the contact angle, you might calculate the surface energy of you punya ni lah, of you punya MOS2 nanoparticle ni. How does it interact with the surface? So kena tengok dia ada heat ke tak, and then you can check benda tu is apa dia punya tu adalah hydrophobic or hydrophilic. So wettability ni when it come, dia akan you differentiate dia based on the hydrophilic ataupun hydrophobic ataupun oleophobic ataupun oleophilic ataupun super hydrophilic. So all the contact angles tu dia ada range dia. So how do you define you punya nanoparticle ni? It contribute to what type of surface? Panjang lagi you punya cerita study you ni. What you are doing is basically like 10 to 20% je, Raziq.
Oh, okay.
Because it doesn't prove anything. You just like showing the characterization of the MOS2, and then you are using also the cooking oil, not the real oil. So that is why I said your satisfaction, is it prove your objective or not? Because knowing you punya objective ni, dia beritahu first synthesize and characterize. Yes, you meet the first objective, and the second one is to investigate the effect. So apa effect yang you checknya? Macam tu.
Oh.
But basically as a degree punya student, we didn't expect much lah, but it's good if you can explore more because this is a 1 year punya project. So I believe, and then you are also doing the lab work, so I believe your understanding is much more better as compared to your friend yang tak sempat nak masuk lab. But it's okay. I can see your effort over there. So it's just that perhaps like a little bit on the understanding you need to polish a bit, and then on the surface area tu saya belum tanya lagi tu, why do you need a higher surface area? Kenapa?
Okay, about that.
Kenapa tak low surface area? Tapi tak apa, don't worry. I think I leave it to you. You ask yourself, whatever you are doing, setiap benda yang you buat tu, you need to know the reason why. Okay, so I think that's all good, Raziq. So I have another presentation after this. So I wish you all the best in your future endeavors. So hopefully in what you are doing, you ni lah berjaya lah insyaAllah in the future.
Thank you,
Okay,
Doctor.
alright. Okay,
Thank you,
thank you
Doctor,
very much.
for the explanation and
Okay, no
exposure.
worries.
Okay.
Okay. Alright, thank you very much. Okay, bye. Assalamualaikum. Take care.
Salam, Doctor. You take care.